Okay, so now let's take a look at how data scientists approach problems, because there's generally a process flow that we follow for most problems. So let's take a look at it. So this is effectively the data science process right here. This image is not mine. It's taken originally by Hilary Mason and Chris Wiggins, but basically it conceptualizes a lot of what I want to explain here. Data science process. So now what we do first is that we take data, we find it from our data sources, we clean the data, we explore it, find patterns and trends in the underlying statistics, and we model it, do the prediction models, and then we interpret the results. So we can go through each in detail. So in every course, and including mine, you'll be given data sets to work with. However, in the real world, data doesn't come by so easily. And in fact, finding data can be an arduous task, as it can involve generating complex SQL queries where you need to understand how the data was generated carefully, because you can mess things up a lot. We can actually do it ourselves with web scrapers, or even manually build our own data set. Like, it's going to be tedious, but you can actually do this once the data is valid. So once you have the data now, you got to clean it up. So it's been said many times, and it actually is pretty true, 70% of your time as a data scientist will be spent on this. Wrangling, munching, pre-processing, feature engineering, call it what you want, but getting your data into a form that can be usable by machine learning algorithms is sometimes quite tedious. And my projects actually don't make it seem that tedious, but in reality, I'll talk about it a bit more. It is. So it's the unglamorous side of data science, but it is one of the most important steps. Because you got to get your data ready to be inputted, is that a word even, into your machine learning algorithm in a way that makes sense, okay? Because algorithms take data in a specific format. It has to be cleaned up and processed, and features extracted, features like categorical variables laid out properly. So, there's a lot of data is messy, by the way. Should have mentioned it earlier, but data in the real world is very messy. And you even clean data sets, like clean in inverted commas here, is not clean. You'll see why. A lot of our case studies and projects will involve a lot of data wrangling, by the way. So you'll get used to it. So this is actually why a lot of these cloud-based machine learning tools won't actually replace what data scientists actually do, because a lot of what we actually do is this. And this stuff can't easily be done by AI, at least not yet, because you're going to have AI that understands the business domain, understands what data is important, how it was generated. So, maybe one day it can be done. However, it's not easy yet. And this is the exploratory analysis part. And this is where you do a lot of cool visualizations and try to understand like the underlying trends and statistics of the data set. So we call this the exploratory data analysis, or EDA. And it's very helpful. Basically, why is because we can detect patterns, anomalies. Those are like outliers and bad data effectively sometimes. And it's also a good sanity check to make sure data makes sense, because you want to always inspect your data carefully before going ahead. Because sometimes you can have something like where, as simple as like wrong currency or like a price before VAT, that type of stuff, it messes with your data a lot. And the modeling part. So modeling data is a part where we actually build our machine learning models. So we use these algorithms here to create a model. So data is usually split into two parts. So training data set. This is what we use to train our model on. Like, our model only sees this data and basically forms the statistical underlying like mathematical equations using the training data set. So this is how we build our model, and then we use our model on the test data set, which is the unseen part of data, and we assess its performance. So this is a critical step right there. We train on one set of data and we test on another to validate its performance. And then we have to interpret the performance. So there's a lot of metrics here. I won't explain this diagram, but I will explain it later on in the course. Basically, we need to know the model's strengths and weaknesses. And we need to have a proper understanding of if this model is applicable to the domain we're working in. And if not, or if it is, what can we do to make it better? And we also need to know how to communicate its effectiveness to the people who are using the model. So yeah, basically it goes back to the example I was looking at. like with diseases and stuff. You want to have a model that always gets it right. As in, sorry, always finds a disease. Doesn't always have to get it right, but always has to find the disease. That's the key point. Same with fraud, actually. You want to find the fraud. If you identify fraud and it's not fraud, it's okay. But if there was fraud and you missed it, that's bad. And then the last part here, which wasn't in the diagram initially, but it is an important part, is deploying this data, this model, into production. And this is where data engineers and software engineers come into play. However, in recent times, I've seen a lot of data scientists are basically being asked or being told they have to do this part of the project now. In my case, happened to me too. So you will actually, it's very, very good and useful skill to have to deploy working models into production. Because you're going to have to understand how it scales, how to make it secure, how to make sure that it doesn't crash, how to make it like work fast, all these things. It's quite difficult, but quite fun too as well. Okay. And also we have to actually, once you deploy a model into production and said it's 90% accurate, that's accuracy is on your training, on your test data set. You don't actually know how it's going to perform on new real world data. So you actually have to continuously monitor and assess its performance, because data can change, like patterns can change in the data you use. So you're going to want to do some model evaluation every so often. So like I said before, communication is vital for a data scientist. And here's a famous quote, or basically a thought experiment or survey that was done. Basically, I don't know where I got this from, but I remember reading about it. It basically was asked to a lot of executives in the audience, what was a more important skill for a data scientist? The ability to build sophisticated deep learning models, or the ability to make good PowerPoint slides? And the majority of the audience said the latter, PowerPoint slides. And that is because a lot of people need a data scientist to communicate effectively what their findings actually are. It makes no sense sometimes to have all these amazing models and you're not really communicating what they actually do, how they achieve what they achieve, or what they're good at or bad at. So you're going to be, and what they can do for the business effectively. So you're going to need to know how to communicate properly in the business world to make your data science projects relevant. So that's it for this section, and now we're going to move on to the course part and how you basically use this course to become a complete and basically hireable data scientist right now. So thank you.